This is number 3 off of the last minute FRQs. So f and f prime are differentiable functions. Values of f and f prime are given at select values of z in the table. If g of x equals f of x quantity squared, find the instantaneous rate of change of g at x equals 9. We can rewrite this if we want as bracket f of x squared, and that's just to help remind us that if we want to find the derivative or instantaneous rate of change, which requires us to find g prime of 9, we're going to have to go through chain rule because we have this function within a function. So there's an outer portion, which is the bracket squared, and there's the inside function, which is the f of x. So we take turns with each of these derivatives. So bracket squared becomes 2 bracket to the first power. We just do power rule, treating this like a variable, times the inside function's derivative, so f becomes f prime. So here we have our g prime equation. So now we're going to find g prime of 9. Replace every x with 9. So we get 2f of 9 times f prime of 9. F of 9, we look at our table here, f of 9 is just going to be negative 2. F prime of 9 is going to be negative 4. So we get 2 times negative 2, which is negative 4, times negative 4, which is 16. G prime of 9 equals 16. For part C, k of x is equal to f of 3 of x times x squared plus 1. Find the slope of the line tangent to the graph at x equals 3. So we want to find the slope of that line tangent. We need to first find the derivative. So to find the derivative, we see that this is represented as two expressions being multiplied together. We're going to have to go through product rule. So f prime g plus f g prime. So f of 3x, derivative becomes f prime of 3x times 3. There's another chain rule going on within this f of 3 of x we got to take care of. Okay, moving on to the rest of product rule, times the g function, no changes, plus f function, no changes, times g's derivative, so x squared becomes 2x, 1 goes to 0. So now we have our derivative for k spelled out. Replace every x with 3, and let's see what we have. F prime of 3 times 3 is 9, times 3, 3 squared plus 1, f of 3 times 3, which is f of 9, times 2 times 3, which is 6. And then we look at use our table to fill out the rest of these values here. F prime of 9 is negative 4. F of 9 is negative 2. So combine all these together, we get k prime of 3 is equal to negative 132. Okay, part D. Evaluate the definite integral of f double prime of 3x dx. So we know that f double prime is going to turn itself into f prime, but there's a 3x we have to make sure we keep track of. We're going to go through u substitution. So we'll let our u value be what's inside here, 3x. Derivative du over dx equals 3. Solve for dx, we get du over 3. We make our substitutions. 3x gets replaced with u. Dx gets replaced with du over 3. We push that 3 out as 1/3. 1/3 f double prime of u du. And now we have, we can apply the first theorem here. So f double prime becomes f prime. And then we plug in our upper and lower bound. But here's something we got to be careful about. F prime of u, we don't want to stick 3 and 0 with u because these don't match, right? We have a mismatch in variables here. So I found the antiderivative, but I'm going to bring this back in terms of x, and now I can safely use the 3 and 0. Okay, so now I have my antiderivative with the x replaced after this u substitution, and I bring it back in terms of x. Now I can plug in my upper and lower bound. So upper bound gets plugged in first. We get f prime of 9 minus lower bound, f prime of 0. F prime of 9, we look at our table, is negative 4. F prime of 0 is negative 3. Right. With the 1/3 attached in front of both, and we get 1/3 times negative 4 minus 1/3 times negative 3, which is negative 4/3 plus 3 over 3, which is negative 1/3. All right, last few here. Let n of x equal to the depth integral from 0 to x squared of f prime. Evaluate n of 3 and n prime of 3. Before we find n of 3, let's just go ahead and find n prime of x. So we just have everything in front of us, we can just plug in. So n prime, that means I have to find the derivative of this expression, and we know that if I apply a derivative on top of the depth integral, they're going to undo each other. But we got to be careful with this x squared here. Let's use our full knowledge of second fundamental theorem of calculus, which says that if I want to find the derivative of a definite integral, my upper bound is going to get plugged into the variable of the expression, multiplied by the upper bound's derivative times p prime of x. So if we do that, follow the process here. We plug the x squared in for the t, so we get f prime of x squared. Notice that no changes here because these two operations kind of just cancel each other out. X squared, we need to multiply it by the upper bound's derivative because this d over dx does have an impact on this x squared, so times 2x. All right, so now we have n prime, a definition for n prime, we have definition for n of x. So now let's find those specific values. N of 3 is the depth integral from 0 to 3 squared. 0 to 3 squared, that's the same thing as 0 to 9. So depth integral from 0 to 9 of f prime. We don't have, okay, what we're going to do is we're not going to do any sort of Riemann sums with the f prime graph because if we do, then first off, we don't know which method to use, and also if we do that, then we're left with an approximation, but we want the exact value. So we're going to make this push up to f of x. So we're going to go through first theorem. F prime becomes f of x. We plug in upper bound minus lower bound. F of 9 minus f of 0. Now we can find exact values. F of 9 is negative 2. F of 0, using our table of values, is 5. So negative 2 minus 5 is negative 7. N prime of 3, we look at our definition here. N prime of 3 equals f prime of 3 squared, which is f prime of 9 times 2 times 3. F prime of 9 is negative 4, using our table of values. Negative 4 times 6 is negative 24. All right, last few here. Let q of x equal natural log of f of x. Find q prime of 5. Notice that this is a function within a function, so if we want to find the derivative with a function within a function, we have to go through chain rule. So the rule for natural log of u is u prime over u. So the derivative for our u value is f of x, so we get f prime over f of x. All right, we're just following the step of natural log of u. Okay, so now we have our derivative. Plug in 5 in for the x's, and we get f prime of 5 over f of 5. F prime of 5, using our table of values, is 3. F of 5 is just equal to 4. 6 over 4 is 3 halves. Okay, last one here. R of x equals f of natural log of x. Find r prime of 1. Again, we have a function within a function. We have to go through chain rule. So outer function is f parentheses, f of parentheses. Inside function is a natural log of x. So we take turns with each derivative. F becomes f prime of parentheses times inside function's derivative. So natural log of x becomes 1 over x. We fill in the parentheses with what we see inside. And now we can use this to help us find r prime of x. So, r prime of 1. So we can replace x's with 1. F prime of natural log of 1 times 1 over 1. Natural log of 1 is 0. F prime of 0, we lose our table of values. Table of values tells us f prime of 0 is equal to negative 3. Right? So we end up with negative 3 times 1, which is negative 3. So r prime of 1 is equal to negative 3.